In the 1980s, before wireless headphones existed and before Wi-Fi speakers were a thing, there was an audio port known as Toslink or SPDIF that's still present on modern devices. And it's got a secret. A simple modification that can be made to it that allows it to transmit audio completely wirelessly with zero latency and no compression. Something even state-of-the-art wireless protocols can only dream of. The key to this modification lies in the fact that it's an optical port. It doesn't use copper cables, but instead relies on a clear plastic fibre that transports light from one end to the other. The light it transports is from a red LED, which flashes on and off extremely rapidly with an encoded digital audio signal. So long as this flashing light can be seen by a Toslink receiver, it will deliver fully uncompressed, dual-channel audio without any perceptible latency. It's a fairly robust signal as well. Splitting a cable in half still allows the light through, even if the two halves don't actually touch, meaning that there's an air gap. That's technically wireless audio right there. Now, seeing as all this cable does is constrain the light from the LED so that it's visible at the other end, would it be possible to get rid of it entirely if we replace the LED with a light source that doesn't diverge? Like that, say, from a laser diode. The light output from a laser diode barely diverges when compared to that of an LED, so an optical fibre isn't necessary to transport it long distances. It can just shine there all on its own. To see whether this will work with a digital audio stream, I've got a cheap audio encoder that can take an analog audio signal and encode it into the SPDIF format through a Toslink connector. And taking the back off, we can see the 3 pins that make the Toslink transmitter bit work. Checking this out with a multimeter, it appears that there is a signal voltage going through it at almost 3 volts, which is pretty convenient because low-power 3-volt laser diodes are readily available on places like Amazon. Being Class 1 lasers, they are low power enough to be considered safe. No fires and no burned eyeballs. Hooking one up to the 3-volt signal, we can see that it immediately illuminates, and is presumably flashing at the same rate as the LED, hopefully containing all of the audio data as a result. So that we can hear whether it is working, I've got a similar SPDIF adapter, only this one receives a digital audio signal and converts it to analog, rather than the other way around. Now, a Toslink port always includes a little plastic hinged cover, so this needs to be removed first so that the laser can reach the receiver's sensor unobstructed. Having the laser illuminate this tiny sensor though does require quite a bit of precision, so to mitigate this somewhat, we can cut a strip of HDPE from a bottle and fold it into the opening. This strip fully illuminates when the laser hits it, making the receiving surface significantly larger. For testing purposes, I'm just mounting it to an old bookshelf speaker, which has a little battery-powered amplifier hot-glued to its back. So here we have our transmitter with its new laser that hopefully contains all of the audio data encoded within it. And the receiver is obviously over here on its speaker. So when I remove this piece of paper, we should, in theory, hear completely lossless, lag-free digital audio. That's pretty cool. Now, the distance that this works is really surprising. It can go through 4 sheets of glass into a different building if you want it to. It's pretty wild. And again, I'd just like to emphasise that this is completely uncompressed audio and lag-free, something that's simply not possible with other wireless methods like Bluetooth. Now, of course, it is line of sight required, which does limit its usefulness somewhat. However, it still brings to the table a lot of really interesting DIY audio product opportunities, the most exciting of which, I think, is a homemade wireless surround sound system. This would eliminate the requirement of draping speaker wires all over the place. The audio can instead be beamed straight to them wirelessly. And as it's optical, it won't interfere with Wi-Fi signals or have any latency issues. For making them, while we could just strap receivers onto old bookshelf speakers just like this, I've been wanting to make a proper DIY surround sound system for literally years, and I've come up with a design that strikes a really good balance between both performance and price, using some very interesting construction